Okay gang, Tom here. We're going to do a little tutorial video here. It's going to be a long one, I think, but here we go. This is about my push button panel, and I had it all working before, but there was this one little minor problem with it when it was working, and I'll explain that in a minute. So right now the system's off, so you don't see no lights on, but these push buttons have an LED in them, and it's green and red. And when you push the button, and it's always green when it's turned on, and then when you push the button in, it changes the turnout, no problem, and the LED goes to red. And so what's supposed to happen is, if we go over to my JMRI panel, this is just one of the many panels I have, but we'll use this one as the example. You can see that all the turnouts have a green icon. And I made that change to make that color because then it matches the panel and everything. They're blue and then they go to red. So what's happening is when I push the button on there, it remains green. So it doesn't send the signal to JMRI telling it to, hey, the turnout changed. So if I hit the panel here and with the mouse and click on that little circle there, the green circle, that'll change it and it'll become red. If I use my power cab and select accessory 144, which is the number of the turnout, all these blue numbers are the turnout numbers, and it'll change it from green to red. So that was the problem. So now, to resolve the problem, we came up with an electronic circuit that I had to build, and with the help of my friend from JMRI, and we got it working now. So what we had to do was, this is the turnout table in JMRI here. Now currently, if we look at, let's take 150 for an example. All the turnouts are set to monitoring in JMRI, so that I can click on the panel to change it. When JMRI starts, it checks all the statuses of all the turnouts and then presents the table, the panel with the right orientation for the turnout. And also I can use my power cab to change it. So that's how all of them are set up now. So since the Cobalt IP digitals don't send the code down the DCC bus line to JMRI, we had to add a sensor for the turnouts. So if we look at 141, which is one I just did, yesterday, and we now have the feedback mode 1 sensor, and then feedback sensor 1 is SY006. So now if we go back, that's how we have to change it in JMRI. So now when the sensor is triggered, it'll pick that signal up from an NCE AIU01, which is where the sensors are, and it'll send the signal down, and now the turnout is known. I don't know why these are thrown. Oh, I must have clicked them. when I was going through. So that's what we do in the JMRI to set it up so that they'll so JMRI panels will know where the turnout is at. Now we go over here, and what I had to do was, like I said, I had a circuit, and I'll show you that circuit in a minute, is we had to get a relay, and it's a 12-volt relay, and that relay then is connected to, underneath the layout here, the wires, and then it also connects to an AIU-01. Now, I have 17 turnouts that I have Cobalt IP digitals on, and I needed 2 AIU-01s because the AIU-01s only have a capability of handling 14 devices. So I have 17, and I'm planning to put some more in later, so I'll have room for more. But when I put those AIU-01s in, I ran into a bus problem. And that problem was I had too many feet of bus wire and had to cut some lengths properly. And I'm still working on that, but right now they're all working. And I got a powered UDP, which helped that out. So now this has made that a nice long project, because this all started with this button board, and then you see how it snowballs into other issues and other problems. You think you got it, and then something else comes up and you have to change things around. So that's what's interesting about wiring, and that's why I like it. So the relay then, once I push the button in, it sends a code to the it sends voltage down the line to the AIU-01, which then triggers the sensor, which then JMRI says, oh, you've changed, and let's change the turnout on JMRI panel. So that's just a quick overview. Now if we go over to my workbench, and here's my diagram. That's the Cobalt IP, and we're using ST, S2C, S2R, S2L here. And mainly I'm using S2L because the orientation of the turnouts or of the motors are in the right position. Once in a while I need to use STR because when I turn on the system, the LED is red instead of green. So when it's red, it should be green. If it was plugged into this one, then I have to plug it into this one. So now what we do here is from S2R, we go to pin 16 on the relay. From S2C, we go to a 12-volt power supply on the minus side, and then the plus side of the 12-volt goes to pin 1 on the relay. Then we have a diode IN4007 between these two wires, and that stops any current coming down and going back through and going up to here and causing damage either to your relay or to the Cobalt IP. This pin here goes to the AIU ground, which is a common ground wire. This pin here goes to the AIU 1 to 14. Down the bottom here we got a DCP SPS12. It's a 12-volt power supply. It's provided by Cobalt, DCC Concepts. It allows the Cobalts to have power for the LEDs and the push buttons. And then you got the white wire coming out of here going to this pin. You got the green wire coming out of here with a resistor on it going to the LED pin, which is for that push button. And then the red wire goes to this pin. And then the other LED wire from the push button goes to this pin. That completes the circuit. So that's that. So what I was doing originally, this is the relay. And as you can see, the pins on there are really tiny. And there we go. And I was soldering stranded wire onto those pins. I need 7 wires, as you can see from the diagram. And what was happening is I had a 3D printed holder, and I was mounting it on the wall this way, and the stress of those wires hanging down, some of the threads that didn't get soldered, that's why I don't like stranded wire to solder, it ended up touching one of the other pins, and that was a problem. So I then changed it to solid wire, and that worked, but I'm going to change those to the new method, and that's going to be here. And I'll be back in a little while to show you the new method, and we'll see you in a few minutes. Okay guys, I'm back. So I was telling you about how I was using solid wire on these relays, and what I did was I put a piece of double back tape, which is there, on the top here, and then I would stick it up into on the bottom of the layout. Well, one of them dropped already, and that's only after a couple days. So, and as I was installing one of these setups here, I'll show you in a second, I must have touched the wire on one of these solid ones, and it fell off. Like I say, these pins on here are so tiny, there's not much room to solder onto. So then we came up with using a PCB board, and the relays slide right into those holes, and then you just turn it over and solder them on. So I did one, and that's what it looks like. These are the 3 relays, so I can get 3 on the board. And then these are 3-pin terminal blocks and 2-pin terminal blocks. So that gives me 10 screws for each relay. And when we look at the diagram, there's only 7 wires involved. And you say, well, why do I need 10 screws? Well, on the diagram, this is the diode. And on the diode, it has a gray ring around it. They're hard to see. Maybe if I get one that we can see. Now it's the background, but there is a gray stripe around it, and that's on the diagram here. We see the diode, and that gray stripe is represented by that. So what that does is when current is coming down here, it won't go back through here. This stops that from happening. So what I was doing was, because it's only a one-way, the diode's only one way. So what I was doing was I was splicing these two wires and then soldering this diode onto here, onto that wire. And then they're just dangling in there. And I said, I didn't like the way that looked too much. So what we did here was on this here relay panel, the two 2-pin ones, I couldn't find 1-pin terminal blocks anywhere, because I needed 3 on this side, 3 on this side, and 1 here. Because if you look at the orientation of the pins, it's going to be hard to see. Maybe if I put it sideways, you can see better. This pin on this end here, there's a bigger gap between that and this one, the next one. And these 3 here are equally apart. So it's like you skip one. They'll be all equal in distance. But anyway, that's the orientation. So you only need 1 pin, 1 terminal block here for that pin. But since I had 2 pins, now what I can do is I can put the diode and connect it to this screw and this screw, and that'll protect those 2 wires. So it'll be a neater and cleaner installation. So I put a diode on this here, 2 screws, and then another diode here on these 2 screws. And that'll protect the wires coming out of those other screws on that 2-pin. So that's what it is. And what I did, Jim Tedesco and I came up with this, and this is a holder for the PCB board. So if we look at it, if I can do it with one hand, there it goes. That's the holder, and I can screw the wires into there and to that side, front, back, easy enough to screw the wires in. The people that I bought the terminal blocks from, it was Amazon, but the company, they provide you with a screwdriver with the terminal blocks, and it fits the screw perfect. And you're always looking for the right size screwdriver when you do this. So that's that. Now this board here is almost ready to be put in place. What I got to do is put the diodes on it, and then add the wire to it, and then put it on the layout, and then connect the three turnouts to these individual relays. This one here, I don't have it soldered, and that's how I set it up. So what I do is I solder the relays on first to the board, and then I solder the terminal blocks on, because then I know I'm lined up. Because if you look at the back of it, all the pins line up across the top there. 1, 2, 3, 1, 2, 3, 1, 2, 3, and etc., etc. Now, the other thing is, when you look at this and you look at the diagram, you go, oh, this is pin 1. Well, no, it's not. So what we have to do is we have to turn it upside, backwards, and this is pin 1 on this side, this is pin 16. So what we do is when we flip it over, this is pin 1. So in order to keep my orientation correct, and I use different color wires for this, I took a photo of this, printed it out, and then I wrote down what wires go to which screws. And this is my green wire, which is this wire here. And this is a white wire, and that goes to S2L or S2R, which is these two. Okay? This is a green wire that goes to the AIU ground. This is a white wire, goes to the AIU 1 to 14. And then over here we got our green, white, and red. And that's green, white, green, white, and red. So underneath the layout, the wires are all these same colors, and it's easy to match up. Most of them are connected to a terminal block that allows me to put multiples on. Like for the 12 volt, that gets connected to a terminal block. So the 12 volt wires are connected to the back end of the terminal block, and then these go into the front end because I have it all looped. And down here, the same thing with this 12 volt power supply. Those 3 wires go to 3 different terminal blocks, and then these wires here connect to the terminal block so that they can get connected and go from there. So my next step is to add the diodes to this, and what I do is I just bend them over, cut them off, and then slide them in. And in the middle two, this one and this one, I use tweezers and a little convincing to get them into those holes. It's tight there, and then I screw them down and they're good to go. And then I add the different color wires. So I'm going to prep this stuff, and then I'll be back and show you what it looks like, and go from there. We'll be back in a little while. Okay guys, I'm back. I did a little prep work here, and so I made the diodes. I cut them off, and that's the gray bar there that goes around, and that goes on pin 1, which is this here screw. So what I do is I just stick it in there, I did loosen up all the screws before, and put it like that. Hope you can see that right there. So what I do is I take the screwdriver they provided, tighten up that screw, tighten up this screw, and now the diode's on there. The next one, what I did was I made the longer side the bar, so I would know without looking at it. I think I did that on all of them. Yeah, the longer side. That way, because it's hard to see that bar sometimes. Now to get it into this one, these get a little tricky. So what I do is I screw it in. Whoops, see, it falls out. Put it in there. I got to get it in there so I can screw it down and keep it in place. There you go. Then I take my tweezers. Now I know how end gauge guys feel. These small things. And what I need to do is like hold it in place while I screw it. It's like you need a fourth hand sometimes. There's two in, and the third one see, that one didn't come out this time. Yeah, sometimes this is tough to get. In there, there's not much room to play around with. But fortunately, the wire is forgiving. It's hard to see if it's in the hole or not. I think I got it. Yep. A little perseverance. I think that's in. Well, we'll tighten it up and see what happens. Nope, it's not in the hole. So I'll be back after I get that in there. I'm not going to sit here and let you watch all this. I'll be back. See you in the next session. Okay, I'm back. It took a little bit to get that one in there. So now all the diodes are in. And now the next thing is to put the wires on here. So the first wires, I skimmed all these wires and everything. And these here are a certain length, so I gotta make sure I get the right one. Okay, the shortest one goes on the top. So according to the diagram, the green wire goes on the left side. Screw it down, and the white wire goes on this side. Hold on a little bit. And the next one this one. Excuse me. White wire there, and the green wire. These turnip blocks are pretty close together. It's kind of tight, but with a little patience, you can get the wire in. Once you get it in there and screw it down, it's in there good. Go there. And then the last one. White wire goes in there. Sometimes the stranded wire is a pain sometimes because you just missed a hole and then all the strands come apart. I try to twist it tight so that when it goes in the hole there's nothing loose, but you always get one little strand somewhere. There it goes. Sometimes you need two hands to okay. So they're the wires that go to the Cobalt IP. So the green wire goes to the plus on the 12-volt power supply, and the white wire goes to the S2L on the Cobalt. And then after I get all the wires in there, then I slide this in here, and then I labeled the turnouts. So first one is 146, then 151, and then 150. And I know which wires, because I know the bottom one is 146, the middle one's 151, and the top one is 150. So we can go from there, and then I'll be back later. I'll put on all the rest of the wires, and then I'll show you what it looks like and get it up on the layout, and we'll go from there. So we'll be back in a little while. Okay guys, I'm back. I got all the wires on, and the green, white, and red wires on this side. Over here, the green wire goes to the AIU ground, and the white wire goes to the AIU 01 pin. These here. And these here I showed you before, they go to the Cobalt IP. And it's all set to go. I slid it into the case, and I put a screw here and here. It's a number 2 56 thread 1/4 inch self-tapping screw, and small enough that I don't have to screw in a lot. So now I'm going to mount it on the layout and probably hook up the wires. By that time it'll be lunch. I'll have my lunch, then I'm going to go out and cut the lawn, and then I'll come back and do another one. And once I get them all on, I'll show you the panel all lit up, and push the button, show it go red, and then we'll go over to the JMRI panel, and we'll see that it's red there also. So that's it for this session. We'll see you in the next session. We'll be back soon. Well, good afternoon, guys. After some many trials and tribulations, finally got it all working. I had a 12-volt power supply, which I need to trigger it, and that stopped working. So I got a new one, and then I plugged it in, and it still didn't work. And I had to change the terminal blocks. For some reason it wasn't connecting properly on the terminal blocks. I put 4 new terminal blocks in, and then it started working. And then I had a couple of, since I was monkeying around with the wires, and I had to pull a couple of them down and reseat them and stuff. So now they're working. So if I push one of the buttons, it should go red. And we'll just take this one here. Okay, it went red. And if we go to the panel, that's 156, and he's red. So now if I go on the panel here and click on it, it went green there, and now they're all green there. So finally got this project done. I had to do a new PCB board, and I got to make another holder for it and put that up on the underneath the layout there. So, but I'm still printing something else right now, and eventually I'll print another one and mount that up, and then they'll all be done. So now I can work on something else finally. So that's it, guys. If anybody needs any help on getting these things wired up, let me know, and we'll be glad to assist you in that. And I got a couple more turnouts to put in, and at least I know what I have to do to get them to work. And I'm going to use the Cobalt IPs for those new turnouts I got to put in. So another panel I'm going to make. And also on this board, I'm going to put a blue LED, because the new power supply I got doesn't have an LED on it. So I'm going to put it on there, connect it to the wire, and then when that's on, I'll know that I have power, and it'll be on the board there. But I'm waiting for some 3mm LED clips. When you drill a hole, you put the clip in, then you can stick the LED in there and it won't fall off. So I ordered them, and they haven't been shipped yet, but they'll be coming out soon. So that's it, folks. This is Tom, and hope everybody has a great weekend. I know it's only Thursday, but we'll see you all in the next video. Everybody, take care.